Let's now look at the carbon-13 spectrum. So generally, like I said before, this ranges from 0 all the way to 220. So again, this side is upfield, and then the numbers increase this way, and this side is downfield. So normally between 0 to 20, you have CH3s, and then 20 to 40, you have CH2s. And then you can see that as you attach the carbon to an electron withdrawing group, then of course you move downfield. So a carbon attached to an oxygen is usually between 60 and 80. So here 60 to 80. Now this is a methoxy group. It's also attached to an oxygen, but it's a special group. So a carbon of a methoxy group, which is attached to an oxygen, very similar to this, but this is a CH2, this is a CH3, and this whole group is called a methoxy. This carbon here appears between 55 to 60. Carbon-carbon double bonds or carbon triple bonds here, and aromatic carbons are usually around 110 to 150. So in this range here. And we know this is a carbonyl. Now this, because it's attached to an oxygen, so remember a carbonyl, if written like this, is the same as a carbon attached to oxygens. So because oxygen is an electron withdrawing group, this is way downfield. So normally between 160 to 220. So again, the carbon-13 spectrum gives information about how many different carbons there are in a compound. Let's look at peak intensity. Generally, if a carbon has no hydrogens, it's going to be shorter, and we call these ipso carbons. That is, carbons with no hydrogens. If a carbon has hydrogens, then it tends to be taller. So here is an example. We have this carbon here, which does not have a hydrogen, so we're going to expect it to be shorter. And then these carbons here are attached to hydrogens, so they're going to be taller. So based on this range and where the carbons appear, depending on whether they're attached to an electron withdrawing group or not, we can see here we have 3 different carbons. This is attached to a carbon. This carbon is attached to 2 oxygens here and then 1. This carbon is attached to 1 oxygen. The more electron withdrawing groups a carbon is attached to, the more downfield it's going to be. So this carbon here, because again, remember this is similar to C, O, and then another O. So this is going to appear way downfield. So that's that carbon. So these 2 here, because they both have hydrogens, they appear here and there. So they're slightly taller than this carbon signal. So how do you differentiate between this carbon and that carbon? Because this is directly attached to an oxygen, it's going to be more downfield compared to this. So of these 2 signals here, if we label them, this is going to be 2, and then this one is going to be 3, and this one will be 1. So again, because this is attached to an electron withdrawing group, it's going to be more downfield. And then this is not attached directly to an electron withdrawing group, so it's going to be upfield. So you can see that this, like I said, is similar to this one here. So that's a methoxy, and we said a methoxy is usually between 55 and 60. So you can see it's between 55 here and 60.